which are we going to cover? Supply chain risk analytics, transportation analytics, business process reengineering, e-commerce and manufacturing, sales and operation planning, interior business planning, production planning, productions and discount optimization, pricing and revenue analytics, warehouse optimization. So whatever algorithm which I mentioned there in the third column, right? They are all limited. Means they're on the summary level. We'll be covering more of them. Inventory analytics, spend analytics, demand forecasting. So this total complete end-to-end supply chain modules, and we'll be doing analytics on this end-to-end modules. And the course is revolved around if you go on a little bit top, it will be revolved around forecasting. It will revolve around yeah, just little top, just little bit top. Hello, Bhushan, are you there?
Yes. Hello.
Yeah, hello. So just go little above. I'll just yeah, this is the one. No, just yeah, there is a one. So we'll be covering the entire modules. Total modules will have these six aspects. So we'll be focusing on the advanced forecasting modules like GARCH, ARCH, Fourier series, ARIMA, SARIMA, and Fourier series is something very important model for forecasting, and which requires knowledge of trigonometry knowledge we need. So we'll be covering that's the most important model for your series. Arch and Garch, which is actually taking care of the volatility, how volatile the sales history is very uncertain, very uncertain. So we have to forecast the uncertainty. So how to forecast the uncertainty? That also we will be studying in the Garch and Arch. In Arima, Sarima, when there is no patterns are available, or if there is a patterns, then you have to remove the patterns. After removing the patterns, how you forecast Arima and Sarima. So we'll be working on simulation, various simulation techniques, various optimization techniques, predictive analytics, machine learning. We're also covering some because in supply chain was a huge application of Six Sigma. We'll be only focusing green because in predictive analytics we are covering the black belt. Six Sigma black belt techniques are covered in predictive analytics and simulation optimization. So we'll be covering a little bit of this green belt aspects, which are very important. TQM total quality management aspects like Pareto's process charts, right, quality charts. Those are very important parts. From the Six Sigma point of view, which we need to put into analytics. And we were learning the advanced Excels. Like yesterday, we were talking about data model, which last session we were talking data models, right? Data models, statistical tools, all those things we cover in the advanced Excel. Data analysis tools, solver, different statistical functions. All those things will be. We are doing something on the forecasting already. We have done the Poisson distribution, binomial distribution. We have done a bit of that already. So there are many for statistical formulas already there in Excel, which we'll be using in real time. As
The
a, as a,
voice is gone.
yeah.
Very good.
So, as a supply chain professional, what we need is a good knowledge and a good knowledge and optimization, a good knowledge and simulation, a very good knowledge on the advanced forecasting, a very good knowledge on the machine learning, predictive analytics. Of course, supply chain professional must understand the supply chain. There is no escape from there. Supply chain must understand supply chain very, very well. So, but these are the tools. These are the tools which we need to have. These are the tools which we need to have to run supply chain with immense visibility. Because if supply chain or somebody supply chain professional is there, he wants to do very good job. In running the company or running the business or running the function, what he needs is information or visibility. If he has a
You're not audible, Krish.
not audible at all,
Very low, very low. The words in between are getting mixed.
probably there is an internet issue. You're using mobile internet or you're using mobile? I think
No, I'm using Wi-Fi now, but I guess you're speaking far away from the from the laptop.
so. So what I'm saying is that uh, as a supply chain professional, we need visibility, we need information, we need insights. Right? If you get the insights, we can actually
Yes.
we can control the present, we can control the future, and we can learn from the past. Three things very important. We have to learn from the past. We have to control the present. We have to manage the present, and control the future. This is the most important aspect for a supply chain professional, right? There are a lot of operations which happens like creating the purchase orders, right? Doing the creating the requisition, releasing the materials, receiving the goods, dispatching the goods, doing the production, making the packings. These are all the operations in supply chain. But to run those operations, right? To run the operations in a direction, to run the operation in a proper direction, in a direction which we have set, like a strategic goal or a tactical goal which is set, which are important with the customer perspective. We need to have a proper visibility. We need to have a proper information, and that visibility is we need to know what has happened in the past, and we need to learn from the past. Right? We need to manage our present, and we have to control our future. So for those three, this is what we actually build through this program. We build the program in such a way that people learn these three aspects: learn from the past, manage the present, control the future.
Okay.
So this is what the crux of our training program will be. And we're launching it from 10th of December. So we started the registrations already. So if you are interested, we can enroll you. As of now, you're learning the demand forecasting full-fledged course. Demand forecasting full-fledged course. And we are teaching you, each and every aspect of demand forecasting. We are learning everything from the scratch from us. So this course will be covering a lot of modules. As you can see at the bottom, the modules which you can see, they're covering plenty of modules, plenty of case studies. A lot of case studies will be there. So the number of algorithms which I mentioned, like the logistic regression, multiple regression, chi-square, these are all limited. Means we will do more what I have mentioned there. So since we cannot put everything over here, so we didn't put everything. Just we will do more than what we have mentioned.
Okay.
So it will take 6 months. 6 months to complete the course. And initially we'll start the course with 6 hours of training. Later on we'll increase to 8 hours. Once we build the momentum, once we start learning the subject, once we feel comfortable, right, then we'll be doing 8 hours per week. Initially it will be 6 hours per week.
Initially 6 hours.
Yeah, initially 6 hours. Later on we'll make it 8 hours. Means based upon the speed of our course, based upon the comfort of our team.
Mm-hmm. Sure. Let me think over it and I'll get back to you on this.
Yeah.
Okay.
I have shared the same brochure on your email also.
Sure. Yeah, I've received your email. I've received the email. I'll go through it. I'll definitely get back to you on this.
Okay, so yesterday we have seen the Poisson distribution. Not yesterday, in the last session we have seen about the case study on the Poisson distribution. Now this time we see a case study on the exponential distribution. And this case study on Poisson distribution and exponential distribution has an important application on min and max calculation of the inventory.
Right?
The min and max. What is the minimum inventory we need? What is the maximum inventory we need? And
Okay.
what is the reorder quantity? What is the reorder quantity? Means, suppose you want to build a purchase order, right? We need to place a purchase order. So how much quantity we need to put on the purchase order? So this particular amount of volume, but what should be your purchase order to the supplier? Suppose your company is a trading company, for example, and you need to get the and suppose of course a trading company, but you're not ordering from suppliers. You're ordering from your warehouse. Just give me a second.
Mm-hmm.
Just give me a second.
Hello. Hello.
Hello.
Yeah.
Hello.
Yes,
Hello.
please.
Hello. Hello.
Am I audible to you?
Hello. Hello. Hello.
Hello.
Hello,
Hello.
madam. Hello. Hello, madam. Yeah, I'm able to hear you.
Okay.
Yes. So So as in the last session, we have seen how to use Poisson distribution, and Poisson distribution is used for a rare kind of outcomes and rare independent kind of outcomes. And here, between the interval, between we have seen how to build intervals, and we have also seen how to measure the flow of outcomes between that interval. An interval is not necessarily this is time interval; it can be any interval. Like we have seen the case study also, where we build an interval which is not time or which is not any duration. It was something like we did a case study where we took the interval as the countries, boundaries of two
Yes.
countries.
Yes.
So like this, we can build a Poisson distribution, which is a very important distribution when we are calculating. I mean, building a simulation table, right? Simulation table of what should be your inventory, what should be your inventory for a particular interval, and we did build a simulation table for that, right? We have taken several kind of volumes, and we built the.
Yes.
Now we'll build the case study for the exponential distribution, and where we are going to use the exponential distribution to
Mm-hmm.
build our min inventory or min and max inventory.
So we'll be only using this while inventory analysis.
Yes, we'll be using this for inventory optimization.
Okay.
Okay, so let's create a table now. So let's build a table now. In this, we'll first build a pivot table.
Okay.
Yeah, so let's put our items on the row.
What will be the other
Yeah, so
column?
we'll put our the weeks or months. I think we have read of months, right? Months on the column, and values, the quantity as the values. Okay, so let's copy this. Let's copy this data and paste special values.
Okay.
So let's build a frequency and frequency percentage. We have to know, we have to build because we're going to use only for rare outcomes. So frequency and frequency percentage.
This should be the criteria should be in double inverted commas, right?
Yeah, yeah.
Okay.
So the frequency percentage is 11%. So this is 1/9. 1/9. 1/9. Okay. Now let's do the filter. Filter and we'll sort only less than 30%.
$675.
Yeah, I think we have most of the items with less than 30% demand.
Less than 20% at it.
Yeah, less than 30%. Right? We have most of the items which we have is mostly less than 30%. Okay. Now, what is a concept which we have studied about exponential distribution? Concept is that suppose in the Poisson distribution we had between two intervals, what is the outcomes, right? In the exponential distribution between two outcomes, what is the interval?
Yes.
Right? That's what we have studied. In that interval, right? How many outcomes? So suppose if you say the outcomes, like the outcomes are, let's say the demand here, right? The outcomes are demand here, like 1850, 30, 2000. They're the outcomes. Okay. Now, what we are saying that in the case of Poisson distribution, we'll say the average demand per hour or per month, right? Let's calculate the average also in the before column K. Let's calculate the average also.
This is wrong, right?
I think we should divide it by 9. Let's find the total divide by 9. Total divide by 9. You already have a total, right?
Yeah.
Yeah, you already have a total. But divide it by 9.
Yeah.
Right, now we know that for exponential distribution, right, the average is 1 by the average of
Lambda.
So here lambda is how much? Let's say if, for 9 months we have, for the 9 months, we have a 9 months duration, right? The interval is 9 months. So here the average
Yeah.
is 206 per month,
Yeah.
right? 206 per month. Now, if you want to calculate the average for exponential distribution, you can just mention that average is equal to Poisson, right? Average Poisson. POI, double S A, POI, POI. Yeah, okay. Now, same thing, you can mention the column M, average for exponential distribution.
One by average, right?
Yeah.
1 by lambda.
Yeah, 1 by average. You can mention the standard deviation also. Standard deviation is also 1 by lambda for the exponential distribution. Same, whatever is average is the standard deviation.
For exponential, right?
Yeah, for exponential. Whatever is our average is the standard deviation for exponential series also.
Okay.
See, now, so exponential distribution in Poisson distribution, what we have seen between an interval, right? What is the, suppose we have taken an interval and what is the demand between that interval? Now, what you're saying is that in the case of exponential distribution, it is like a demand, right? Between a demand, we will have an interval. Our intervals will be demand now. Between that demand, what is the interval? Right? Suppose now what we are saying is that we are going to break our entire in the like we have a demand. Like demand is let's say 20, and let's say we have a demand called 1000 to 2000 for the item number 1, 1528, right? The row number, the item number, the first item is 1528. If you look at the row labels, just make it items. It will be confusing later on. Instead of making row labels, make it give a name called items. In this data, make it that as item, not row labels. Okay. So what we are saying that now, let's say the first item, right? Materials. The first material is 1528, right? So let's say my demand. I will take it. I will take a interval now. The interval is 1000 to 2000. Okay, 1000 to 2000 is my is the interval, because like whatever is the interval in Poisson distribution, whatever is the interval in the Poisson distribution, that becomes the outcomes for the exponential distribution, and whatever is the outcome for Poisson distribution, it becomes interval for exponential distribution.
Exponential.
So now let's say that my interval is 1000 to 2000. Demand is between 1000 to 2000. Right? Now in between 1000 to 2000, we will have what? Our periods. Means like Jan, Feb, March, April, May, June. Right? Now let's say between Jan and Feb, let's say Jan. Let's say Jan. Jan is how many days? 30 days. Right? So in 30 days, out of that 1000 to 2000, how much demand will get in Jan?
Okay.
Right, we will have the 12 months period, right? Jan to let's say our demand is 1000 to 2000. That's our interval now for the exponential distribution. 1000 to 2000. In between 1000 to 2000, what we have? Our 12 months.
Yes.
So in the 12 months, in the first month, out of 1000 to 2000, how much demand will get? In February, 30 days, out of 1000 to 2000, how much demand will get in the month of February? Out of 1000 to 2000, how much of demand will get in the month of March? Out of 1000 to 2000, how much demand will get in the month of April? Out of 1000 to 2000, how much of demand we're going to get in the month of May, like June or July or August, like September, like October, like November and December?
Yeah.
That is what we have to calculate in the exponential distribution.
Okay.
Right? So in the month of January, how much demand will get from in between 1000 to 2000? How much demand will get in between 2000 to 3000?
Got it. Got it.
So we need to build a simulation table now.
Okay.
So let's build a simulation table, and this will be between let's from say 0 up to
0 to. Will I do it here or in the name sheet?
here only will do. 0 to, first we'll put 0, then we'll put 100 up to 5000. I think up to 10,000. Let's say up to 10,000. 0 to 10,000. With a gap of 100. Let's build a table up to 10,000.
That is huge, huge, large number of colors. Okay. Now,
Now we use the formula. The formula is exponential distribution.
first one or second one?
Yeah, first two.
Exponential dot distribution.
Yeah, yeah. Exponential dist, right? What is x here? 0, comma. What is lambda here? Here I am confused. The lambda we should use the 1 by lambda 1 by u.
Lambda, in this case, we should use the one derived from
Let's try
somewhere.
it. Let's check it. Let's check. I think yeah. No, not this one. 1 by lambda, right? Yeah, 1 by lambda.
Yeah, 1 by lambda of the selected.
But that is standard deviation. I think column L is.
That is for poisons that we are
Oh,
derived.
okay, okay. And let's put cumulative. No, non-cumulative. Yeah, just drag it and let's try. I think you have to put the dollar sign, otherwise it will not work. I think. You have to put a dollar sign for just make it workable by putting dollar signs.
R1 network.
Look at vertically also.
Okay, 1 and 3. Where it's working vertically.
So it is Q1 and M3.
Q1 is this 0
Yeah.
and M3 is the average standard deviation.
Yeah.
No.
Yeah. So now we have to see. So we have numbers now, and we see what is the most likely. What is the most likely thing to happen? Right. So we can do a color code now. Anything less than less than one, we'll put it green. Anything more than anything less than zero, we will make it red. Anything less than, I think there is error is also coming up.
Yeah.
So go to the frequency. Anything is 0%, remove that. Let's go and filter. Let's go and filter. Remove 0%. In the sorting, go to filter and remove 0% also. No. Select. Go to number filters. Yeah, keep it there. Go to number filter. No. Yeah. Select all. Select all. Select all and go to number filters. Select in between. Go to number filters. Select in between. Yeah. More than greater than equal to 0.01. 0.01. Less than equal to 30%. 30%. 0.3. Click OK.
No, we applied for 20 only before.
Oh, 20 only, right? We didn't mean 30.
20.
20. Oh.
We'll have to drag the format again.
Okay. Okay, so now we'll conditional formatting. Anything less than zero, first we'll make it yellow. Oh, sorry, we'll make it red. Anything less than zero, we'll make it red.
Okay. There is no data for this one. Okay. Conditional formatting.
Yeah, condition formatting. You have to give it less than, right? Less than. Less than zero. Green. Custom format. Okay, click OK. I think you have to also make change on the 4.5, right? It's not 4.5. Select red here, red. We want red on. Red. You have to make a change on the, click OK, make it 0. Yeah, click OK. Now check whether it's working or not. It's not working.
There were some errors here in between. Because initially we took it for like 20, So
So I think we have to do conditional formatting once again.
We'll have to.
Yeah, the negative value is there, right? Negative value is there. I think in this table, where in the demand table, wherever is negative value, make it 0. Control F and 0. The demand table, not there. In the demand table. Demand table means our sales history.
I did that, I guess.
Oh, but why still getting that? Go to the Poisson distribution value. There is one error there. There is one error. Why are we getting that error? Select all. Unselect all. Unselect all. Go to the last. Go to the last value. There is a minus also coming somewhere. I think there is some minus is there. Second value is minus. I think first value is minus. Second value is minus. Why are we getting minus there? Okay. So
Minus is there in the grand total.
okay, I think we have to change that. I think it's not that. It's not minus. No, I think go back to the form. Go back to the unfilter everything. Remove the filter. No, it's not. It's still wrong. Remove the filter. Now write the grand total formula using a formula sum. Yeah. Now let's check whether we have still have minus 11, right? Minus 11, minus 9, minus 14. There are three, not one. There are three values. There are two more values over there. Minus 9, minus 4. So we have to filter it from frequency, right? Frequency more than 0, more than 0.01.
Yeah. Still have this error over here, number 7.
Yeah, that will come because we have 0. The lambda is 0 there. Wherever we have 0%, we'll get it. So we have to sort the data from frequency table, frequency row. in between, in between. Now do the conditional formatting. Anything less than 0 is less than 0. Okay, now go to custom format. Make it red. Okay, it's red. It's only red only there. Click OK.
So okay.
Select once again. Select data once again. Select only two, 3 rows, not all the rows. Okay, you have selected very well. Now go to the conditional format. Now wait here. Wait. Yeah. Click OK. We'll see whether it's working or not. Click OK. We're going to go back to the conditional formatting. Conditional formatting.
Let's try for one row. No.
There are no values getting less than 0 there. Okay, so there is no value less than 0. Okay, it's working very well. There is no value less than 0. Okay, so let's say equal to 0. Let's do the formatting for equal to 0. Now you select the entire table. It will work. I think we don't have enough data points here. Right there, equal to point triple zero. Change the value. Point triple zero. Yeah. Okay. Now let's put the value. Let's put condition formatting more than 0.001. Select all of them. All of them. Condition format more than 0.001. Greater than, equal to, point 0.001. 0.001.
0 point?
0.001. Yeah. Green. Make it green. Make it green.
Yeah. Quite good.
Okay. Now let's reapply, edit the rule. We'll make the change in the rule. Let's make change in the rule. Go back to formatting and select the entire. Now we have select the entire means values. We'll make the rule. Yeah. Condition formatting. Make a rule. Make it 0.5. 0.5. Same rule. Same rule. Make it 0.5.
So the bigger values are only in the first row there.
I think we made some error here. I think the value cannot be more than 1. Put the lambda of exponential distribution. Put the lambda of exponential distribution here. Go back to the formula in the beginning, the first cell, and put the lambda of the exponential distribution. Sorry, Poisson distribution. Yeah, we're getting more than that. Right? I think that's good. Go back to the previous one.
Mm-hmm. No.
Go back to the previous means M. Instead of L, put M there.
Yeah, I changed it. You want me to change it for everything?
No, it's back. Go back to the. Go back to
M.
M for Madras. So probability of getting the highest. Now we'll change our you know lambda for exponential distribution. Oh, sorry, for Poisson distribution. Right now we have this lambda for how many months per month, right? Average is per month.
Yeah, for 9 months. Yeah.
Yeah, average of 9 months. This is the average average of 9 months, right? This. So let's calculate the average of for 3 months. Now, keep it there. Keep it everything there. Now we insert a new column, and we'll say the average of 3 months. Everything, let's keep it like this. No need to change anything. Now we'll calculate average of 3 months. 3 months average.
This is Poisson's, right?
Poisson. So we don't have to use the Poisson formula here. No. We don't have to use the formula. We have to calculate lambda, right? We're calculating lambda for 3 months. This is a calculation of lambda for 3 months.
This is 3 months.
What is the formula you're using?
Since we have calculated dividing this by 9, I divided this by 3. So this is calculated by the total divided by 9 months. So I just divided the total by 3 months.
I think we have the grand total for 9 months.
Yeah.
We have a grand total for 9 months, right?
Yeah.
So we have to multiply the average by 3. Yeah, that will be the same answer. 3 into 3, 9. 3 into, yeah, same. So there are 3 months, right? Now we'll calculate the exponential. Now we'll calculate lambda, 1 by lambda, right? 1 by lambda for exponential distribution. 3 months.
Should I change the values over here?
Yeah, now we can change the value. Just let it put the change the lambda, right? Just the change the lambda. Now it was M, now it will be R. Not Q, Q, yeah, Q. Sorry.
Okay.
Now say let's do the color formatting or conditional formatting. This is 1 by lambda, right? This is not lambda. This is 1 by exponential lambda. Correct. For 3 months. So like this, we can build for 6 months. We can build for 9. We can build for 1 month, 2 months, 3 months. Same thing, more than 0.5. Yes,
No. How much
more
value?
than, more than 0.5. Same. Keep it same.
Point?
0.5. Everything is same. Nothing. Let's click OK. Apply and let's check where we're getting the green colors here. Check the entire other cells also. Right hand side.
All the other ones are like smaller.
Now let's check the frequency. We have frequency less than 30%, right?
Yes.
Now let's check the frequency more than 20%. More than 20% and less than 30%. In between, more than 20%. 0.2. Yeah. As demand is increasing, the probability is decreasing here. Right, so everything we're getting the probability of getting a zero demand in 3 months. In the first three months. Every 3 months. Now we'll do one more thing analysis here. There is a data here. If you look at the demand data, this data is in the first half there is no demand, second half there is a demand. In the first half there is a demand, second half there is no demand. look at the demand data, is the history data, the month 1 to month 9. There is a demand at the end of the year, like 8th month, 9th month, but there is no demand in the first, second, third month. There are some areas where we have demand in the first, second, and third month, but we do not have demand in the last 3 months. Can you see that? The demand data?
Yes, yes, yes.
Yeah. So if you look at these areas where we do not have demand, right? In the first, we have demand in the last months. There you have the probability coming of zero, more zeros, and wherever we have demand in the beginning, we are getting higher probabilities.
Yeah. Cool.
So let's go and select the green areas, or go and filter by color formatting. Select only green.
We haven't applied it for here. Let's apply the condition formatting first.
Now change it to 0.3 instead of 0.5. Make it 0.3. And apply the filter and select by only color. Okay. Now okay. So now let's do one thing. Let's go back to the 0.2 to 0.3 filter and remove the color filters. Remove the color filters.
In the quantity?
No, color filter is in the in the exponential distribution calculations. Right? Now let's go to cumulative probability. Clear filter. Clear filter. Now let's put the cumulative probability. Instead of false, let's put true. Instead of false, let's put true. Okay, let's go back on top. Okay, now let's go to color filter, conditional formatting, and change our value to 0.75.
Two 2.75. 275.
No, 0.75. 0.75. Look at here, why we have put 0.75? We want to understand the most highest likely value, which you can decide to have an inventory? Right. So this is a value for every 3 months, right? We are using for every 3 months.
Yeah.
So this is 0.72, 0.92. So if you look at, we can easily keep an inventory of with a 99% service level. Suppose we want to have a service level of 99%, right? We want to have a service level of 99%. So we will go with at least
At least minimum 400.
400, up to 400, in between 400 to 1100.
1100.
So we can keep an inventory of 1100 for every 3 months. Or per month it will be 300. 300 to 400. Right. What is second case? In the second item, what is a service level? If you want to go with 95% or 19, that's 99%. The second item means that is keep going on, keep going on. I think we have to go with test the green, right? Or we can change the condition formatting also. We can go and only put 99%. We don't have to search like this. Change the condition formatting value to 95. Let's put 95%. 95%.
Let's put between 95 to 99.
No, not between 9. No, don't put anything between. Put less, more than 95. 95, yeah.
Because less than if we consider, then this one will disappear. It's getting highlighted.
Yeah, you can do that also. You can change the formatting from 95 to 99 or 98.
Mhm.
Right, so we can choose the inventory and based upon this. In the first case, itself, what should be our volume for every 3 months?
Yeah.
So this is how we build our so, service level based volume. For items which are having rare demand, very rare demand. If you could have some more data points, would have been more useful to us. But since we do not have, we need to do 20 to 30%. Now we have done for 3 months, right? You can also do for 12 months there.
Yeah.
Now we can keep an inventory of 100 per unit for 12 months.
For 12 months, right?
Yeah. Every month you have to keep 100 units.
Each month, right? Each
Yeah,
month
each
I have to keep an inventory of 100 units.
100 units like this for 12 months.
Okay.
The second case, how much we are getting? The second item. What is the 99 per? Where is the green?
It is starting from here actually.
Yeah, this is 3,400.
95.
Not from there. You can put 947. 947 is where? 947. That is 1300. 947. 3,200. 3,200.
From here.
Yeah. So you can start from 3,200 per month. So you buy inventory of 3,200 and stock it.
Yep. Sold.
So this is service level, right? Service level best. And service level always has to be decided based upon the cumulative probability. You can make a note somewhere. Service levels are always decided based upon the cumulative probability. Service level percentage and its volume. Service level percentage and its volume is decided based upon the cumulative probability. Based upon the cumulative probability. Okay. So this is all about the exponential distribution. Now we'll do the last case on normal distribution. The last case is the normal distribution. So
Normal distribution.
So let's copy the data, raw data which we have built for the exponential distribution. Let's copy that and paste in new sheet, only raw data, not the calculations.
This one?
Raw data means your item, the Jan, Feb month, up to grand total. We want all the data here. We don't want just zero digit. We want all the data. Means I think the filters are applied here. There. Remove the filters from there. We want all the data points, just not the.
Okay.
Now here we're going to select only data from more than equal to 30%. So let's
More than?
Frequency and frequency percentage. Calculate the frequency and frequency percentage, and take data more than 30%.
Okay, more than 30%.
So now what we'll do is we will compute a formula. We use a formula called norm dot inv. Before that, we'll build a simulation table, simulation range. Let's put there 15%, 0.15, 0.15, 15%. That is not 1.5. That is 0.15.
Point?
0.15. 0.15, 0.20 up to 99%. Or 0.20. Like this, you can build up to 100%. Okay, now let's use a formula called norm.inv. Below
Yeah.
it equal to norm norm.inv, not this. No, inv. Norm dot
This one?
second one. Norm dot inv. Yeah.
Okay.
Select the probability, comma. I think we need to also find the standard deviation and average. So let's remove the formula and find the standard deviation.
Mean and standard deviation.
Yeah, we have to find the mean and standard deviation for each of the items. The column and just insert one more column there. Insert one more column before O and find mean and standard deviation.
Mean will be the average, right? Yes.
Yeah,
Right?
yeah. So you have to use the formula stdb.s.
I have to select the range, right? Here.
Yeah.
Number 1 and number 2.
Yeah.
Correct?
Yeah.
It is coming as error.
Use the formula if error because there is only one single value.
Coming as negative 34.
What's the formula you have used? P1. P1 is what? Okay. N17 is what? Mean. N17 is what? Drag the formula. I think you have to create the dollar signs, right? Create the dollar sign.
Yeah.
Generally, it should not do more than one. I'm very surprised it is going more than 6.5, 6.3. Let me check this. Okay. So this is what we're getting is okay. So let's do one thing. Let's copy this up to standard deviation into. Let's copy the data up to standard deviation and paste it to a new sheet. Let's copy the data observation. and paste into a new sheet. Okay. Now let's put the volumes there from the cube. Let's put the volumes. The volumes will be like 5. Let's put the smallest volume. Let's start the volume from 5 till 2000.
2000.
Yeah, from the volume start from 5 and drag it till 2000. So this we are building a simulation table now. Let's use the formula norm.inv equal to norm dot dist, sorry, not inv, dist, norm dot dist. Yeah. Choose x here 5, comma, mean and standard deviation.
Cumulative.
Yeah, we'll put cumulative as true. Right, now we do the color coding. Color coding like this, like in between 0.95 to 0.98. We put green.
Sorry, 1 point.
We'll do the color coding now. Color coding between 0.95 to 0.98. Green. 0.95 to 0.98.
19.
5 to 0.98.
Till
0.98. Make it green. Green, 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 green. So wherever you got 0.95 to 0.9, that is our inventory. We need see the all these volumes which were mentioned on the top, 5, 10, 15, 20, 25. They are the volumes, right? We need to decide for the inventory as an inventory.
So 20 units we need to keep for the second item, right?
Yeah. So the first item you get a service level of 0.99. First, the volume is 5, right? If you decide to keep an inventory of 5, you get a service level of 99%. First item.
Yeah.
So what we are looking for is 95%, minimum 95%. So second item, you can keep an inventory of 20 units. Third item also, you can keep an inventory of 20 units. Fourth item, again, you have to keep an inventory of at least 40 units, 45 units. Fifth item, you have to keep inventory of at least 80 units. Right. Sixth item, you have to keep at least an inventory of 15 units.
So this will give us like a more of an visibility that how much we should be selling.
Yeah, this is giving us based upon service level. How much is service level, and what should be the volume for the service level?
Considering the fact that the service level for every organization they expect to be like 99%, considering all the difficulties and problem scenarios, we consider like 95%, then also it can give us a good visibility. Right?
Right. So this concludes how to use our Poisson distribution, binomial distribution, exponential distribution, normal distribution to come up with a volume-based decisions based upon service level.
Guys, this is good. This is something new I learned.
So what we need is we need to for every new models we need to test before we deploy. We need to test, so we can check it for 2 quarters and see whether our decisions based upon this are coming true or not. If they're coming true or closer to true, then we can start applying these models on our data. It's not like we have to start applying from the very next moment of building the model. Right? So this is how we have to build the models, and now we have to test them. So we test on your real data. And if they're coming right or coming closer to each other, then you can start applying them in the model.
We can do a trial on data from the model.
Yeah. Okay. So this completes our distribution based forecasting, and we'll move into pattern based forecasting from our next session. Okay, we'll let you know your interest on the supply chain analytics. If you are okay, then can
Sure. I'm thinking on it. I'll let you know on that.
sure. Okay, Bhushan, then we'll meet on Saturday, right?
Tomorrow, right? Tomorrow we have this regular one.
Yeah, tomorrow we have regular. Yes.
Tomorrow. I was thinking, Chris, instead of keeping it on Saturday and Sunday, what is happening? Eventually, some unexpected plans are coming up. Like, for example, yesterday I have to drop my brother to the airport. He was actually, he's working in IT. and he came back to India in last April. So around during the COVID situation, and around for 8 months he was here, and now since the they have Singapore has started allowing people to travel, he just went back yesterday. Better that we keep it in weekdays only, so it does not. We don't have any difficulties since my office is there. I don't plan anything. So as we are having this on Tuesday, we can have it on Thursday and Friday instead of Saturday, Sunday, early morning, same time schedule. Is it okay for you?
Yeah. Because right now I don't have any sessions in the morning. So Tuesday, Thursday, and Friday, right?
Tuesday, Thursday, Friday. Yeah.
Okay.
Tuesday, Thursday, Friday.
Yeah. So I'll
Great.
modify the schedule and I'll send you.
Sure. Thanks.
Okay then. Take care. Bye.
Okay. Thank you. Bye bye.